section 1.5. Divisions of segments and angles. So in this section we will be cutting up angles and segments, and kind of what is the language that we use to describe that. First, if we cut something in half, it's known as a bisection. Typically, we use a point to bisect. For example, we could call this point R. If we knew that these two distances were the same, from P to R and R to Q, then we would know that R bisects. Now, theoretically, we could even use a line like such, yeah, to bisect that angle or that segment as well. Careful, we cannot bisect things like rays or lines, because obviously they're infinite line length. That point then that bisects is called a midpoint. So a point that bisects a segment is referred to as the midpoint. And here's a little example. If we take OP and we say it's bisected by K, yeah, with two little hash marks, then we know that those distances are the same. And K is the midpoint of OP. All right. Next, well, what happens if you cut it into 3 equal parts? Yes, so that each of these distances down here are all equal to each other, DE, EF, and FG. Then those 2 points, E and F, that divide the segment into 3 points are called trisection points. Yeah, so I'll highlight them here. So E and F are trisection points. Next, we'll look at a angle bisector. So in this case, we're going to take an angle, not a segment, and here we have our angle, yes, FIG, and we will bisect it, and we don't bisect it with a dot, a point, we bisect it with a ray. And when we do, that ray cuts it into 2 equal parts. So this segment here, or this angle, and this angle here are both equal angles, right? And when I put equal hash marks on both of them, that's what that means. All right? So a ray bisects an angle, not a point. In our example here, if we know that this angle and this angle are equal, so I'll put 2 little hash marks in each one, then we know that AB, and again I put a ray on top of it, would be the angle bisector of DAE. Example 2. Angle DAE. So here's an angle. Yeah. And you could say, for example, in this case, that AB is the angle bisector of DAE. Now there's also another angle out here, and you can see that this angle here was not marked, but there we go. We can see that this one here too is marked as 2 angles that are bisected equally. Then AC is also the bisector. So there are 2 bisectors in that diagram, not only AB but also AC. All right. All right. We'll skip this example here. Here's a tricky question. If B and C trisect AD, Does that mean that this ray and this ray or segment trisect the angle? Meaning, are these angles the same? It is tempting to say yes. I'm going to show you here why our answer is actually no, it doesn't. Maybe you can see it. Let's move E really close, like right there. Now we can see, without moving B and C, this angle here is quite acute. And this angle on this side is quite acute. But notice this angle here, though it is acute, it is not as narrow. And the further I drag E to that line, the closer, the more obtuse that angle is going to get. Yes? And again, I'll call that maybe E prime or something like that, since it's not the real E, but I'm just kind of moving it closer. Yes? Again, if you were to bring it in like super close, you would see that that would be quite obtuse, right? In comparison to the other two. So it is not a trisection. Be careful about the things that we assume, right, that are not mentioned. Good news, proofs in this section are only about 2 lines long. This one here says we know that this segment is the same as that segment's. Prove H is the midpoint. Well, that's basically a 2-line proof, because in our statements, we start with number 1, what's given to us. DH is equal to HC. And our reason is given. And then line 2, we need to take and just, well, what's the definition of midpoint? Look back up here. What does it mean to be a midpoint? A midpoint is the point that bisects the segment, right? So we get 2 equal segments, AB, and I'll just say BC. Kind of, well, maybe we should, pardon me, use what we have there. So PR is equal to RQ. Yeah? Then R is the midpoint. So by definition, since we have this, then we know that H is midpoint. And the reason for this is definition of midpoint. So most of your proofs are really short and sweet. It's 2 little lines. You just kind of state the given and then usually state a definition or a theorem. This, however, is a little bit trickier. KO is a bisector and JKM measures 4137. We have to find the measure of half of that. So JKO. All right, that's going to be the question. So to do that, we're going to take 4137. Shouldn't be using a decimal there. 41 degrees, 37 minutes, and we need to divide it by 2. So I'm going to say something like that to start the process off, right? This is how we do it. All right, I'm going to take 41 and divide that by 2. And then I'm going to take the 37 and divide that by 2. We'll do those 2 parts separately. Here I get 20.5, which translates to 20, 30, right? Remember, because it's half a minute, half a degree, so it's half a minute. 37.2 is, I believe, 18.5. So I have 18 minutes, and then again I have half of a minute, which is 30 seconds. So now adding these up, we can see that this is minutes and this is minutes, so I have 20 degrees, 48 minutes, and 30 seconds. Okay? There are other ways to do this too. I think this is probably, I don't know, to me, in my mind, it's the cleanest way. Good luck with your homework problems, as you work with divisions of segments and angles.